Okay, so in this video we're going to take a look at inverse trig functions. Right, so we're going to focus on just our three major ones: uh, cotangent, sine, cosine, and tangent. All right, so I want to focus on just the properties of these, domain range, how to evaluate them, and then the other three, cosecant, secant, and cotangent, we can just knowing these, right, and the fact that they're reciprocals will help us evaluate the other three trig functions. There are some things you have to watch out for because they're inverse functions and not the functions themselves, so there's not a correspondence like the reciprocal for our regular cosecant, secant, and cotangent. All right, but before we get into that, let's look at, first of all, what are inverse functions, or what are the inverse functions of cosine, sine, and tangent. All right, now hopefully you are at least a little bit familiar with, just in general algebra, what a inverse function is. All right, if you are not, right, there's a nice introductory video on our Canvas course page that kind of goes over the basics of a inverse function. Okay, so what we have here is the sine function. So f of x is equal to sine of x. All right. Excuse me. All right. Now, let me mark off at least the first period here. So 2 pi negative 3 pi over 2, excuse me, 3 pi over 2, pi over 2, and of course 0. Okay, now in order for a function, just any function in general, to have a inverse, it has to be 1-to-1. Right? Now what that means, graphically at least, is, so in order for a graph to be a function, or a relation to be a function, it needs to pass the vertical line test. Right? Where if you draw any vertical line, right, it touches the graph at most once, right? Maybe 0 times, but at most once. If it crosses it twice, it is not a function, right? Now, in order for a function to have an inverse, it needs to be 1-to-1. So what that means, graphically, essentially, is that it not only does it pass the vertical line test, it passes the horizontal line test. Now, as you can see here, and as we can see any of our circular functions, that is not the case. So how do we even say that there is an inverse to this function? Well, what we do is we restrict the domain. Okay, now we know for our sine function that the range is from -1 to 1. Right? All right, the domain is all real numbers, but I want to restrict the domain. Right? Now I want to restrict it in such a way that it achieves all the values in the range, but it is also 1-to-1. Now there are an infinite amount of ways that you can do that. All right, where you can restrict the domain, but in particular, and this is how your calculator works, we, excuse me, this should be negative pi over 2. We restrict the domain from negative pi over 2 all the way to pi over 2. So when we're dealing with inverses, the domain restriction is this right here. All right, and now notice that here it achieves every value from -1 to 1, and it also passes now our vertical line test. All right, if we essentially just cut off the rest of it. All right, so this is our restricted domain function, range from -1 to 1. Every single value, right? No matter what the size of the domain, the range is never larger than that, and the domain is from -pi over 2 to pi over 2. right? Notice we could have chosen from 3 pi over 2, all the way down up to here, right? 7 pi over 2, right? But again, we chose this one right here, right? And when you use your inverse in your calculator, and again, we'll talk later how to use that, your calculator, to calculate the inverse, right? It takes into account this restricted domain. So let's introduce our inverse cosine. Right now, inverse notation for functions, right, is used here. Now, keep in mind, this is, the way you read this is inverse of f. It is not an exponent in the way that we think of it. The negative one, you always have to make sure of the context of it. Sometimes it'll represent an exponent, but here when we're dealing with functions, it's representing the inverse. Notation for the inverse, we're working with the sine, is the arc sine of x. And sometimes you'll see, and I should just be sine. Right, these are equivalent notations. All right, our textbook uses the arc sine. It's more descriptive. A lot of times there's a confusion with this. Students will interpret that as an exponent, but if you see this notation, that is not an exponent, that is an inverse notation. All right, now the graph of this. Okay, so if we recall, the inverse is essentially reflecting across the graph y is equal to x,